small shop owner has bought in the Santa or in any Raitu Bazaar.
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
We are Sirpur. We are top on the Everest. Congratulations.
I want to be a leader.
Hi Sweros, today I am here to share my knowledge. So today we are going to learn about something. So before going to start, now I am going to give one example. Okay, see here what I am doing. Yes, I am shaking my hand. And next what I am doing, I am putting this object from one place to another place. Very good. So next observe me. What I am doing here? Yes, very good. I am walking. So in the first case I am here, but in the next case I am here. So now I am unable to touch that object. Why? Because I am away from that object. So that's why I am not unable to touch that object. So when I am moving from that place to this place, what happened? My position is changed. So this is known as the motion. So see friends, today we are going to learn about the types of motions. So tell me friends, can you tell some examples for motion? Yes, tell me some more examples. What friend? Yes, coconut falls from the tree. Falls from the tree. Very good. Next, can you tell some more examples? Yes, very good. Car moving on straight road. Car moving on straight road. Can you tell some more examples? Yes, very good. Tell me what? Movement of cycle wheel. Movement of cycle wheels. Movement of cycle wheels. Yes, what friend? Tell me. Oh, giant wheel. Yes, giant wheel is very good. I like giant wheel to climb. Yes, giant wheel. Yes, friend. Tell me some more examples. Yes, movement of cradle. Yes, movement of cradle. Tell me some more examples. Yes, pendulum clock. Very good. Pendulum clock. Very nice. It is very good. In ancient days, we used pendulum clock only. Yes, tell me some more examples. Yeah, very good. Yeah, what? Yes, movement of butterfly in a garden. Yes, movement of butterfly in a garden. Yes, tell me some more examples. Molecule in an atom. Very good. Excellent. Molecules in an atom. Can you tell one more example? Yes, tell me. Okay. Movement of planets. Movement of planets. So friends, these are the examples. So here coconuts falls from the tree we have. So here we can see that this is a tree. So from this tree the coconut is falling from this tree. How it falls? Yes, it falls in a straight line. So this type of motion is called the translatory motion. Or else we take what we have here, car moving on the straight road. How it moves? It moves in a straight path. How it is moving? In the road, it is moving in a straight path. So this type of motion is known as a translatory motion. What? Translatory motion. Translatory motion. And tell me, here what we have? Movement of cycle wheels. Yes, movement of cycle wheels. How they move? For example, if we take this disc, how it moves? Yes, how it is moving? In a circular path. And or else we take this train. So, how this train is moving? Yes, in a circular path. So, this type of motion is known as circular motion. Circular motion. Next, what we have here? Movement of cradle. Okay, wow, here we have a cradle. How it is moving? Yes, it is moving to and fro. How it is moving? To and fro motion. Or else we take a pendulum clock also. How it moves? It have a big bob. With that big bob, how it moves? It moves in to and fro motion. So this type of motion is known as a oscillatory motion. Very good. Oscillatory motion. Yes, what we have next? Movement of butterfly. Yes, we see in the garden how the butterfly moves around the flowers. It moves in a random motion. Yes, it moves in a random motion. And molecules in an atom also, they move also in a random motion. It means it doesn't have any particular direction. So this type of motion is known as the random motion. I am writing here random motion. Yes. Next, what we have here? Movement of planets. Oh, movement of planets. How they move? We know that they occupies a particular place and they have a regular intervals. With that regular intervals, they move now. So this type of motion is known as the periodic motion. Very good, friends. What? Periodic motion. So these are the motions we learn. So these translatory motion, oscillatory motion, circular motion, and what we have? Random motion, periodic motion. These are the motions we are written on the board. So we have these many types of motion. Today we are going to gain the knowledge from the motions. So let us see on the screen what are the types of motion today we are going to learn. We are going to learn the definitions of motions today. So what is the definition of motion? Motion is a change in position of an object with respect to time. Motion is typically described in terms of displacement, distance and velocity, acceleration, time and speed. Yes friend, I already told you that here we can see that here one car, it is in the first case how it is backside of the tree. But in the second case what happened here? It almost crossed the tree. It means what happening here? Is it tree moving? No, only the car is moving. Why the car is moving? Because it is in the motion position. So this is known as motion. Today we are going to learn about the types of motion. Let us see what is the types of motion on the screen. So types of motions. The types of motions are translatory motion, oscillatory motion, periodic motion, random motion and circular motion. So what is translatory motion? So see friends, what is translatory motion? The translatory motion means the motion of an object, it moves in a straight path. It means the translatory motion means the object which it covers equal intervals with equal distance is known as the translatory motion. So this translatory motion is divided into two types. One is rectilinear motion and the next one is curvilinear motion. So the rectilinear motion means motion of an object in a straight path is known as the rectilinear motion. We already taken the example for this. It means the car is moving in a straight path. So this is known as the rectilinear motion. and the coconut is falling in a straight path. So, this is the example for the translatory motion. Let us see what is the curvilinear motion. So, the curvilinear motion means the motion of a object in a curved path is known as the curvilinear motion. For example, here we can see that the man. So, how the man is moving in a curved path? How it is moving? He is moving in a curved path. So, the object or a person who moves in a curved path is known as the curvilinear motion. Next, we are going to learn about one more motion. It is the oscillatory motion. The oscillatory motion means to and fro motion of an object is known as the oscillatory motion. It means it always follow the fixed point is known as the oscillatory motion. We can take the example of pendulum clock. In ancient days, they used pendulum clock for the time. So, how they use the big bob is there, no? Here we can see that the big bob is there. So, how the big bob moves to and fro? It moves sidewards to and fro. And in the next case, we can see that here the boy is, when he is swinging, he moves front and back. Here what happening? To and fro motion. So, this type of motion is known as the oscillatory motion. Very good, friend. Next, we are going to learn about the next type of motion is periodic motion. The periodic motion means the bodies occupies a particular position at a regular intervals. Example, position of planets in their orbits around the sun. Here we can see that in the example, here the sun is there. So, sun is the center of all planets and they are moving with a particular orbits. For example, we take earth. Earth have a particular orbit. In that orbit, the earth is moving. So, they occupies a particular position with regular intervals is known as the periodic motion. Next, we can see next motion. So, the next motion is the random motion. So, the random motion means motion of a object in varying direction. It means it does not have any specific direction. For example, we take here, we have butterfly. How it is moving? In a random motion. It means they does not have any particular direction. Or else we take atoms in a molecule. They are also moving in varying directions. This type of motion is known as the random motion. Next, we are going to learn about one more motion. Before going to start the motion, now I am going to show one thing. Let us see what I am going to do. So, I taken one stone and I tied it one edge of the thread and I am putting like this. I am taking this stone like this and I am rolling this thread like this. Here what happening? The object, it means the stone is moving in a circular path. When the object is moving, a circular path is made in here. It means one circular path is formed here. The object is moving in a circumference of the circle. Let us see once more. Here what I am doing, this is the center of the object. My finger is the center of the object. With this center, the object is moving. Yes, it is moving in a circular path. So, this motion is known as the circular motion. Now, we are going to learn about the circular motion and we take this disc also. How it moves? Yes, it is moving in a circular path. So, this type of motion is known as the circular motion. The object which moves along the circumference of the circle with constant speed is known as the circular motion. So, we take giant wheel. Wow, giant wheel is very good. I like to climb the giant wheel also. In the giant wheel, we see that when the giant wheel is moving, it moves along the circumference of the circle with constant speed. It moves, no? So, this is about the circular motion. So, this circular motion is divided into two types. One is uniform circular motion and the next one is non-uniform circular motion. So, let us see what is uniform circular motion. So, the uniform circular motion means the object which moves along the circumference of the circle. It means it moves along the circumference of the circle with constant speed. But when the object is moving along the circumference of the circle, there what happening means the velocity is changes. How the velocity is changes means when the object is moving, every object have a velocity. So, that velocity is changes. So, that velocity is indicates the acceleration also. You get doubt. how it is indicates the acceleration? Yes, how it is indicates the acceleration means we have a formula for acceleration. Do you remember it? Yes, tell me what is it? Very good. It is acceleration is equal to velocity by time taken. Let us write on the board. Yes, what is the formula? Can you tell one more? Yes, acceleration is equal to velocity by time taken. Yes, tell me. Acceleration is equal to change in velocity by time taken. So, this is the formula for the velocity. So, when the velocity is changing means it indicating the acceleration also. Though, so this acceleration is known as the centripetal acceleration with constant magnitude. So, let us see the examples for the uniform circular motion. So, I already shown the examples. The object is here in the first figure. We can see that the car is moving in a curved path. When the car is moving in a curved path, then what happening? The velocity is changing, but it is moving with constant speed. And we already done this. One stone is moving along the circumference of the circle with constant speed. And the gymnast, how they when they are rolling the balls, they also moves with constant speed, but the velocity is changes. So, next we can see that the non-uniform circular motion. So, let us see what is the non-uniform circular motion. The non-uniform circular motion means a object which in this also it is all opposite to the uniform circular motion. When the object is moving in the circumference of the circle, but in this non-uniform circular motion the object moves along the circumference of the circle, but here the speed is not constant. Here when the object is moving along the circumference of the circle, the speed is not constant. So, here we can see that when the boys are skating, then what happened? They are moving along the circumference of the circle, but when they are moving, the speed is not constant. And Columbus, oh, it is very danger. I feel very scared about the Columbus. When they are moving some curves are there, no, I feel very scared about the Columbus. So, because it doesn't have any constant speed, it moves high and low. So, this is about the non-uniform circular motion. So, let us see what is the next motion. So, in this term we learned about the objects are moving in a circumference of the circle, and we learned about the uniform circular motion, non-uniform circular motion, we learned about this. But why the objects are moving in only circumference of the circle? Is there any reason? It means something force is helping to the objects, no? That is why the objects are moving along the circumference of the circle. So, let us know what is that force, why they are moving in the circumference of the circle. Now, we are going to learn about it. So, let us see on the screen what is it. So, the force which helps to the objects to move in a circumference of the circle is known as the centripetal force. So, the centripetal force have two Latin names. One is centrum, centrum means center, and the next one is Peter. The Peter means to seek. So, these are the two Latin names for the centripetal force. The meanings are center and to seek. So, the centripetal force, here we can see that this is the center of the circle. So, one object is started moving from here. When the object is moving along the circumference of the circle, then what happens? The velocity is changes. So, here what happening? The velocity is changing. It means it always moves in a straight line, but the force which acting inside of the circle, it pulls the object to move in a circumference of the circle. So, that is why the objects are moving along the circumference of the circle. So, here we can see that the force which helps to the object to move along the circumference of the circle is known as the centripetal force. It means the centripetal force always acts towards the center. It means it always acts towards the center, and the object also moves in the circumference of the circle. So, this is about the centripetal force. We can take one example. Now, I am taking one bucket. Are you thinking that this is empty bucket? No, the water is there. So, water. And I tied one thread edge of the bucket, and see now what I am going to do. Can anyone do this without falling water? Can anyone roll this in a circular path in front of you? No one. I am going to do now. Let us see what I am going to do. Without falling water, now I am going to do this magic. So here what happening? The object is moving along the circumference of the circle. How it is moving? Along the circumference of the circle. The object is moving along the circumference of the circle. But is water falls any there? No, there is no water. Why the water is not falling? Because the object. So I am writing here distance travelled by the object. By the object. Distance travelled by the object. So here I already told you that when the object is moving in a circular path, the velocity always tries to move in a straight line. So here I am drawing one straight line. So this is velocity. Yes. So I am writing here radius. So these are the two similar triangles here formed. Now what we are going to do means, next here given that change in velocity by velocity, we have to write it as it is. Change in velocity by what we have next? Velocity. And in the next one what we have? Distance travelled. So the distance travelled means, for distance travelled we have a formula. Can anyone know that? Yes, very good. What? Tell me. Yes, distance travelled means velocity is equal to this one side is over, and the next side what we have to write it. Velocity, and next what we have? Into time by radius. What we have? Radius. So I am writing here radius, and I already told you that multiply with velocity, divide with time. So I am going to do multiply with velocity, divide with time. So I am writing here multiply with velocity and divide with time. So I am dividing with time.